Welcome to The Explainer. Today, we're going to get into a really core concept in programming that, believe it or not, has huge implications for how professional software testing gets done. We're talking about inheritance, and a choice that really pits power against practicality.
Okay, let's just dive right in with a simple question that gets right to the heart of all this. In the world of programming, can a single class, a blueprint for an object, inherit its features from more than one parent?
So what's the answer? Well, in Java, it's kind of a classic no, but situation. It's not a hard no, and that little but is what makes this whole conversation so interesting for developers and testers.
And this slide right here shows you exactly what I mean. On the left, you see a class trying to extend or inherit from two parent classes at once. Java just says, nope, can't do it. It's a hard stop, mainly to avoid a ton of confusion. But look to the right, here's the workaround. A class can implement multiple interfaces. Think of an interface like a contract that says, I promise I know how to do this specific thing. So while a class can't have two biological parents, it can have multiple job certifications. That's the compromise Java makes.
Okay, so if you can sort of achieve this with interfaces, you've got to be wondering, why do professional testers actively stay away from building complex structures like this? Turns out, they have some really good reasons to be cautious.
It pretty much boils down to these three big reasons. First, as we just saw, the language just doesn't support it for classes, your main building blocks. Second, trying to force it with workarounds just leads to messy, tangled code that becomes an absolute nightmare to maintain later on. And honestly, the most important reason, there are just way better, cleaner, and more flexible ways to get the job done.
So, let's talk about those better ways. Let's get into the elegant solutions that the pros actually use. This is the toolkit for building test frameworks that are strong, scalable, and, this is key, easy for a whole team to understand.
And this table, this really shows a fundamental shift in thinking. Instead of locking a class into a rigid is a relationship, like a sports car is a vehicle, professionals prefer flexibility. With composition, a class has a tool it can use. The car has an engine. With interfaces, a class can do a specific job. The car is drivable. You see the difference? It's about moving from what something is to what it has or what it can do. That's the secret to clean, modern design.
All right, theory's great, but what does this look like in the real world? Let's actually pull back the curtain and see how these ideas form the blueprint for a real testing framework, like one built with Selenium. This is how the software you use every single day gets tested.
So first up, every single test is built on one solid foundation. There's usually a class called BaseTest, and all the other test classes inherit from just this one parent. That's single inheritance used for all the common stuff like opening a browser before a test runs and closing it when it's done. It's simple, it's clean, and it's super efficient.
Then the tests get their tools. Instead of a test class trying to be the login page, it has a login page object. This is composition. It's just like a mechanic. They have a toolbox full of wrenches. The mechanic uses a wrench, but they are not the wrench. This keeps the tests themselves clean and focused, and all the logic for interacting with a page is tucked away neatly where it can be reused.
And finally, for those special cases, you bring out the interfaces. Remember, these are like contracts. Let's say a few totally unrelated parts of your system all need the ability to export a report. You can have them all implement an exportable interface. This just guarantees they can do that one specific job without forcing them into some weird, complicated family tree.
So, after going through all of this, the rules in Java, the problems with getting too complex, and the elegant solutions the pros use, what's the one big thing you should walk away with?
This quote just nails it. Truly great design isn't about flexing and using the most powerful or complicated feature you can find. It's about having the wisdom to look at a problem and choose the simplest, clearest, most effective tool for that specific job. It's all about making things that last and that other people can actually understand. And that really leaves us with this final thought, and it goes way beyond just Java or testing. In pretty much any field where you're building something complex, you have to ask yourself, is more raw power always better than elegant simplicity? What we've just seen suggests that more often than not, the answer is a clear no.